Those online, can you get those from here, from there? Just indicate we're starting.
Yes, we can.
Okay. Equally, do you see my screen?
We just see
see my screen also in.
Or just seeing freshly.
Okay.
Yes, we can see your screen.
Okay.
Yes, we can. I can
Means
see. Right.
We're good to go. Okay. Let's pray. Heavenly Father, King of Glory, thank you for bringing us here again today. Father, we pray that you guide us and you help us to go through this class successfully, even the network be stable, and that, Father, the class will be a success. Thank you as we pray in Jesus' name. Amen.
Amen.
So, welcome to today's class. We started yesterday with orientation, and we have exceptionally started late today just because we are still trying to give people the liberty to meet up with time. But yesterday we set out the rules for our class tasks as rated. It's good that some persons were here before that. And for those online, we equally recommend. So as we started yesterday, the skills to analyze data is at the forefront of companies, NGOs, individuals today. And so the decision to partake in this training, I believe, is a decision you will not regret it. And so yesterday we did share the outline that we'll cover, and we agreed that as we progress, if time permits, we'll go beyond the outline because we want to do a lot of practicals, bringing even add Excels, more to Excels, so that we should be able to cover as much as we can within the time frame. And we call on us to all participate and support so that at the end of the day, we can achieve the results. So one of the key things we started by indicating is that we do not assume that those taking this class, they already have some pre-knowledge. And because of that, we are starting from the first step. And the first step is actually basic concepts that we need to understand. Data analysis, like any other field, has some concepts, some terminologies that are unique to the field. And having an understanding of these terminologies puts you at the right front to be a data analyst. Without an understanding of these key terminologies or key things that you see over and over, you might face some challenges. And so today's class, we are going to see some of these key concepts. We'll be able to say what data is and understand the difference between data and information. We should be able to understand what population is and sampling variables, levels of measurement. It's clear that we may not cover all of this today, but we intend to use at most 2 classes to cover these key concepts and many more. Now, like we started yesterday, we indicated that the research that we're doing, or data analysis, an aspect of research. And we know that research is a systematic process that has to do with using scientific methodologies to provide answers or solutions to problems. And so when we have that reasoning, the first thing we need to understand is that the approach we're using must be scientific. And so in a research process, you basically start by defining a problem. A problem in scientific terms Must not necessarily mean that you get up in, like, for instance, you get up and you don't have water in the house. Yes, it's a problem, right? But in this case, it's either something you have observed and you can provide a simple answer to it. For instance, I sit and I find that the prices of goods and services keep increasing. It's an observation, right? But now I'm worried, what is the cause? Yes, people might say it's Russia, people might give different reasons, but do I think what others have said, that Russia is responsible for the increased global inflation as the ultimate truth? And with that, you may find that you don't really want to take the answer available as the obvious, right? In such a situation, there is a problem. You now find a problem that needs to be investigated and provide a solution, and to provide a solution from a scientific perspective. Maybe others are just giving their opinion, linking the inflation in Cameroon to what? The Russian or the Ukraine crisis, which might not necessarily have any correlation. And so you have a problem. Now, once you identify a problem from a scientific perspective, it could be that you have seen and observed situation like the one we've just explained, or it's just by studying and reading literature and you've discovered there is a gap. There's something many have studied, but there is a gap that has not been covered, and you believe that you want to provide a solution to this, and you decide to work on it. So with that, you still have a problem that you have observed, and there's a possibility, there's need to study and provide answer. So once that has been done, you also have a problem. So you can get a problem by observation or by studying what others have done to see where there is a gap. In either case, there is a problem you have identified. Now, once you've identified the problem and you have defined the problem, the next thing is that following a scientific procedure, you need to collect data, right? Yes, and to collect data simply means you have to decide, how am I going to solve this problem? Yes, from seeing the problem, we may decide to collect either qualitative data or quantitative data, depending on the nature of the problem that you have identified. And so once you have identified the problem and you identify the source of data, you need to collect that data. Basically, there are different tools that use to collect data, but we can classify two primary data sources, secondary and primary, right? The primary source means you, the person solving a problem or analyzing the data collected yourself. So if I wanted to make a study and I pick up somebody's questionnaire that the person collected the data to do something else, it might be primary data to the person, but to me, it's secondary data, right? Because maybe the person collected the data for different purpose. So when we say primary data, it means the researcher is the one collecting the data. You are at the forefront of collecting first-hand information, because primary data. Now, in collecting primary data, most often we use tools like the questionnaire, which is one of a questionnaire, simply a standardized technique. If time permits, we'll take some time to review how to structure your questionnaire and how to develop a questionnaire. Because instrument development is at the forefront of data collection. It's not uncommon for somebody to collect data, but the data has no relevance to solving the problem. It's not uncommon for somebody to go around collecting data, and you're collecting data on something else, but your problem is on something else. Or you basically pick up a questionnaire, you just pick up questions, you just put questions at random, they have nothing to do with the objectives that you set out to achieve. And so it is important for you to understand that data collection is critical. I prefer that you collect the right data, and if you do wrong analysis, right? But your data should be the right data, because I can discover on the way that when you discover that data is wrong, you go back to the field. It's very costly for somebody who has a good idea about data collection. You understand that it's one of the costly aspects in the research process. And so instrument development is critical. Whether you're using a questionnaire, you're using an interview guide, you're using a checklist, or whatsoever, you must ensure that the instrument is valid and reliable. Right? We have the reliability and validity that are critical aspects that you must ensure when you are collecting data. We can talk about different types of validity, different types of reliability, but that is not really of our prime interest at this particular point. But what we are emphasizing is that as a researcher, the most important aspect of you when it comes to data collection is making sure that the instrument is reliable, the instrument is valid, that your questions you are setting will help you attain the objective of the study. That has a lot to do with defining the problem according to defining the right problem, right? You must define the problem accordingly. And so it is equally important for you to do that. Excuse me. Sorry for that. So now we've said we use questionnaires, we use interview guides, right? We use focus group discussion. We can use checklists. We can use observation, focus group, or checklist goes with observation, and so. But validating these things are critical for you to get the right data. And so as a researcher, it's of prime importance. As a data analyst, it's of prime importance to ensure that that data that you want to use was collected according to the standard. It meets the objective of your study. It meets the problem. It can help you solve the problem. Because if you look at the decision-making process in the data analysis using data, the first thing is that you must define the problem, the right problem, and define the problem right. Define the right problem and define the problem right. They are two different things, right? Collect the right data and collecting the data right. They are two different things. And all of these things must play a role. Analyzing the right data and analyzing the data right, they're two different things. And interpreting the right data and the results and interpreting the results right and making conclusions, they're all relevant in the process. Wherever you make a mistake, if you define the wrong problem, no matter the amount of data you collect, there's probability that you will not get the right result. So define the problem is critical, and define the right problem is also critical. Collecting the right data is critical, and collecting the data in the right way is critical. You don't have to make a mistake along this line, because at the end of the day, right data collected, analyzed, using the right approach, the recommendation should help solve the problem. After collecting your data, you said, yes, when we will go in, if we distribute, if we decide to make the average salary for everybody to be 200,000 francs, the workers will be happy, they will produce, they will be productive. The company increase salaries to 200,000, but that was not a problem. Some workers need a promotion and you're adding the salary, right? Some workers need a training. So you did not define the right problem. But the recommendation you made caused the company a lot, and the problem has not been solved because someone who needed a promotion, his or her problem was not to increase salary. You get that? So defining that problem is critical. And once you've done that, you've collected the data using the right techniques. Now we get to the stage of analysis. And basically, we are not focusing on the other parts that we've indicated, but our interest is analyzing. Our interest is analyzing and giving meaning to this data. How do we get the data to be, we want to train ourselves to be able to bring out meaning from the data collected using scientific tools. We want to train ourselves to be able to make decisions from a logical and scientific perspective. You get it? They will say we want to replace guesses and maybe experience. We want to complement experience with data, because if you complement experience with data, we will have better results. Do we get that? So having said that, what is data? And what is data? Which is the key concept that we'll see. So these are just the basic concepts that we'll have to see when we're starting with data. Right? So I want somebody to tell us what is data. Okay. Okay. It says data is a collection of facts. Do we all agree with that? Do you all agree that data is a collection of facts? Okay, say raw facts. Madam Sandra, you share the same. Oh, okay, he did not say collection. Okay, the data is raw facts according to him. Do you agree with him? Okay, like we can see from the slides, data simply refers to what? Raw facts. We have not extracted any meaning from it. If I show you, hopefully we can see. You look at the slides, what happens? You see these are variables. We'll talk about what variables are. We have age, gender, and what? Duration. If you look at these slides, what you will notice is that at this particular point, this is simply what? Data. Because they're just giving us 18 to 35 years, maybe 34 years, or 34 years, 34 years and above, and so on. We can't really make out any meaning from that, right? But that's data. But when we're processing it, we should be able to have meaning. Maybe should be able to see that looking at the variable age, we tend to have more persons below the age or within the age group 18 to 35. How do we do that? We can just simply count. When we start counting, we see now the information emerging. You're already analyzing, you're already extracting meaning from that data just by counting and see. Maybe look at gender. A quick look, we may say that based on the data, we tend to have more male than female. We're now processing that, but at this particular stage, without adding meaning to it, it's just data, raw facts. We cannot extract. When we start seeing that more male than females, then we are now extracting meaning from that information that from the data we've collected to give us what it is we call information. Now, if that is a definition we all accept, then information, the difference between data and information is that data is raw, the information is processed from data to make meaning, right? Once we process our data through analysis, we can now have what? Information. So information depends on data. Without data, you will not have information. Do we get that? At least in the field of data analysis. Information may be different in communication, it may be different in normal conversation, but when it comes to the field of data analysis, information means what? Processed data. Data that we can act on, where we have meaning and we can be able to use. So basically, that is the key concept that we want to see as data is concerned. So what we are here is to be able to collect this data from whatever source we have. It could be that we collected using a questionnaire. It could be that we have retrieved company records. It could be that we are retrieving the data from a database. We're able to give meaning to it by analyzing it, by processing it, right? And if we don't process the data, we'll not have information. So actually, the goal of a data analyst is to bring information because the decision makers, they're acting on what? Information. That's what we say from the research process, we have the aspect of reporting. Why do you have to report? Because they will not take the report and act on. And so the aspect, having the knowledge of how to report data is also critical. Do we get that? So somebody who has interest in, you hear common terminologies: data analytics, data science, data analysis. These are keywords that you hear when you are interested in the world of data. You hear data analysis, data sciences, data analytics, and whatever. Well, they have slight differences, right? They have some slight differences in them, but they have more in common than differences. For instance, data analytics may be tilted towards company more, where they want to have decisions. That's why we call business intelligence. I want to apply a lot of business intelligence decision making, right? We are helping management to take decisions using what? Data. We're analyzing company data. Apart from just using financial accounting reports to take decisions, you're also tracking customer reports, you're tracking everything and analyzing. Because before now, what companies did is that they basically rely on accounting to take decisions. But today, a company takes accounting. Yes, we have our profits, we analyze whether our profits are increasing. They bring in customers in decision, customer information. They analyze what is happening on their website, analyze employees' behavior, and they combine everything to make decisions. And that has given now the power for data analysis or data analytics over what? Just traditional accounting information for decision. Because with data, we have hard-code figures to deal with, and we also have what? Just text. You will get it. You're listening to me talking. At the end of the day, you can analyze and discover where was emphasis, which was repeated themselves. It shows a point of interest. You will go and you are conducting an interview in the field, and somebody is describing my experience with a war. There's some keywords that are coming out. They're repeating themselves. Maybe that is a point of concern. That is a pain point. Just listening as an individual, you may not be able to establish. You can establish a few, but establishing a list of keywords might be difficult. But with machines, they say, okay, the word, let me say, victimized or beaten came out this number of times. And you start getting more. And many of them, maybe they were beaten. So if they're beaten, what solution? Maybe we should be relocated. We should be, you get the information that what comes out more. That information, with modern analytical techniques, you can get it and make better decisions. Now, we have heard it. Data is the new oil. Data is the future. Data science is the sexiest field. All of these are common things that we hear. Why are they saying? Because these are the leading industries. They're using a lot of, whether artificial intelligence, Internet of Things. We know about Internet of Things, right? They all rely on data. Self-driving cars, they rely on data. Those are things that, as a data analyst, you need to get acquainted to. Internet of Things, you are able to, before you enter your house, the house opens, you ask just, without you necessarily going and putting a key. You can unlock their house when you are not there. There's a lot of data. And so data is collected every blessed day, every second, every human activity. Human or non-human activity generates a lot of data. But this data is not useful until processed to get what? Information. And so companies are looking for people to process this information and help them to process the data, and they should get information that will help them grow. Do you get that? Any question, any worry thus far with what data and information is, with what we have stated thus far? This class should be interactive. We're not teaching like in UB, where the teacher is not final. Yes, this is the only class you have the right to argue and disprove the teacher wrong. We are all learning. It's a learning process. I always sit here because maybe I know better than you certain things in this field. It doesn't mean I know everything. No, I know you. There are things you have experienced that we have to. It's a discussion. You will get that. Yes. So it's not a monologue where the teacher just explains. You are listening. I went to school. There was one day the teacher was brought up a topic, and I said, "But that's not." He said, "No, we don't argue. You're a student, and you take what I say." But that is not the modern day way, I think, to teach. The student should say, "But what we have said, according to this source, is not okay, or according to this is my own experience." Right? So let's make the class interactive. So no question, no worry, any contribution before we move on? Any contribution? Those online, any contribution, any worry?
Not at all. Everything is okay.
So we get that. So Application of data analysis or data science. We started yesterday in the healthcare industry. The doctor sits and you come into the hospital. You are explaining that I have this so and so problem that is disturbing me. The doctor is analyzing to take a decision, right? Or a hospital wants to know which of the diseases has the highest prevalence. Yes, you may be doing analysis. Yes, we're using experience, right? The truth is that your experience tells you that this is the highest disease, but we want that data should be able to support that. You get it? Yes. You want to know maybe which of the drugs. Okay, this is the highest drug that is demanded in my hospital. But that drug is not the highest drug that's giving you profit. You may not be able to think that the highest demand drug is the one that's giving you the highest profit. So for you to take the decision on why this is the highest drug is on demand, and the highest drug that's giving the hospital profits or giving my pharmacy or whatsoever institution profits, you need to correlate and see which one contributes to your profitability the more. So that you may not focus only on buying what is on demand, you also want to buy what is profitable to the institution. You'll get that. Now you have different varieties of drugs. Yes, most of the customers are coming. When they come, they request for this. For instance, let's say malaria. Malaria. There are so many drugs out there that kill malaria, right? And you see, you are selling. They come. Somebody asks malaria. We have Amatem, and so on. All the terms, right? They are requesting for all the terms. But you want to know which one is more effective. Somebody just comes and say, okay, I want to buy this. Based on your analysis, you have discovered that most people are buying this particular one because it's what? It's more efficient. You could recommend that based on statistics, this one can help. The person buys and go and use it ahead. You know, next time the person will call you a doctor, even if you are just selling. The little knowledge of data analysis will help you to recommend, and your recommendation has earned what? Good reputation that you're an expert. You get that? So at individual level, you can apply. At the company level, you can apply. Telecom companies, right? Take the case of a telecom company, MC. The tariffs I have and the one you have, they're different. They're possibly different. There's some adverts that MTN will send to you, although we're in the same location, that I might not receive. Based on your profile, they know that based on your profile, this is what you prefer. If we give you this direct option, you will tend to buy more credit. But we give you this one, you might not. It's understanding the customer. How do we get there? Data analytics. So companies, they use this to understand their customers well and make differentiation and make segmentation. Target marketing. You don't just send out adverts, you are able to target and know that these people are more liable. You get it? Instead of just going to CRTV to post an advert for everybody, you may go on Facebook and say, okay, I'm targeting this group of persons. Facebook has the possibility to say, if you're targeting somebody who's looking for data analysis in Boya, I have 1, 2, 3, 4, 5, and they send them the advert and you discover. That's target marketing, using what? The customer profile. Insurance companies, like we said yesterday, insurance companies have been using data since the beginning of insurance to calculate their premiums and define. Government is one of the institutions that rely a lot on data because government doesn't act based on emotions, right? It acts more based on facts if we're following. So should we send a secondary school to which area now? It's not just because one minister came and said we should send a secondary school. You need to ask, how many students do we have? Do we have enough for a school to be there? Right? So the government is to make effective decision, use data. Finance. We all know banks. How many customers do I have? Right? Which accounts do they which of the accounts? Is it current account? Right? For this particular customer, how often does the person come to save? How often does the person withdraw? Can we be able to have money when the person comes next time? That's the work of a data analyst to track that information, analyze it, and tell the company, based on this customer, we should always reserve this amount of money. This customer should be given a loan because he or she will be able to meet up, and you will get that. So those are some little things to understand that if we use the decision, we can, the education, and so on and so forth. So, in sum, data analysis cuts across all sectors. It cuts across all industries. We use it at the company level, organizational level, we use it at an individual level. I always say before you cross the road, you sit and you stand, you calculate, cars are coming up, down, right? Yes. And so you are imagining, based on the distance of the car that's approaching and your speed, right? And the number of persons on the track, if you enter the road, will you get to the end or not? You are processing that information. You have to say, okay, if I enter now, we said, since it's probability, you may enter and the car knocks you down, right? But 90% of the time, when you do the analysis, you cross successfully, right? Yes, you are taking into account. When you calculate, you think that no, if I enter and I will not come to the other part of what do? You stand and wait until you think that it's comfortable and you have put all the factors, and if you enter now, you'll take a decision that you can enter at individual level. You want to track your resources, your financials. The other day, I was just trying to take statistics of my expenses in Analyst, see which of the domains I spent highest the previous month. Then I see the margin of expenses, the variation from the average I usually spend. You see that the variation is high, it means there are issues. You need to check. Is it high because there was an abnormal spending, or it's a general increase in your expense? If you discover that you are increased, it's a general increase, then you must look for ways to increase revenue to meet up. Otherwise, you start lagging behind. At individual level, if you have can't track your expenses, there are apps that does that. This is what I did. You discover that you spend a lot on food or food-related items. It becomes what? A call for concern to maybe regulate. You get it? Yes. So you must see the relevance from a global perspective and individual perspective. So, in sum, as we make progress, these are some common words that you need to: analytics, business, qualitative, quantitative. There are words that are common in the field of data analysis, decision making, research, and so on and so forth. There are lists of common terminology, statistics, and as you see them. But all of this helps you to be able to take a decision as a researcher. All of these are vital for you to understand that as a data analyst or as a professional, you want to get an understanding of these key terminologies and how they apply in your field. Domain knowledge cannot be overemphasized when it comes to the field of data analysis. Right? There's some statistical techniques that are useful for somebody who is doing maybe who is working in an insurance company compared to somebody who's working in a bank, and compared to somebody who is working in an NGO. There's some techniques that are peculiar. And so that domain knowledge is vital. So having said that, I want us to define data analysis or data science so we can establish our journey. So, what's data analysis? Can you just read the definition? You can see from there. Let's take the definition from online. Data analysis. Okay. Data analysis is a process. That's the first thing we have to underline. It is a process where we inspect, we clean, we transform, we model data, and that all the steps we are taking with a goal of discovering what? Useful information. If you go back to our previous slide, we would have seen the word useful there. Right? We want to discover useful information to make what? Informed decisions or conclusions, or to make decisions supported by what? Data. And so as a data analyst, what you do is that you should be able to what? Process information. You should be able to inspect data. You should be able to clean data. You'll be able to transform the data and analyze the data. The one modeling there simply means analyzing. So in the process of defining what data analysis is, we see that you have to do with inspecting. All of that constitute the data analysis process. Modeling has to do with bringing out, if you are doing predictive analysis, you model the relationship that exists so that you can take decisions based on real facts, analyze facts. And so that definition you can check is given by Wikipedia. So it is vital for us to understand this definition, which means tomorrow, if you're sitting down as a data analyst and you don't know what it means by inspecting, or you cannot inspect, you cannot clean, you cannot transform data, you cannot model, you cannot be a data analyst. So that's what you are expected to do. That's a process of data analysis. We'll see a more large process as we progress, but that is what you are expected to do as a data analyst. Data cleaning is vital. We said 90% or 80% of the time you spend cleaning data. So in analyzing data in a modern day world, we have some key tools that are vital. We mentioned them yesterday. I want to mention them here again just for us to be able to. We have auto-managed programs that we've said, which are some softwares like Tableau. We said Tableau is used for visualization, right? So you should be able to learn Tableau if possible. Tableau is used for visualization. Tableau and SPS, and Power BI, Looker, Zoho, or Analytics, they do the same thing. Visualization and building of dashboard. Visualization has to do with charts, plots, all types of plots. Dashboards has to do with interactive charts. So this is possible with modern day software. So if I were to recommend which one you should learn, well, I said the most important thing first is not the program, right? It's not the program that matters first. It's understanding the mechanics behind. You understand what a bar chart is? You understand what a scatter plot is? You understand what a box plot is? It's more important than deciding which program to use to get a bar chart, a scatter plot. You will get it. But if I were to recommend, I would recommend Tableau because it has a lot of machine learning, artificial intelligence embedded in it, and to me, it's easier to learn. But then, if you go on search online, you discover that there's controversy, which one is easier. Some people say Power BI is easier. But then, it's a catch. Tableau is very expensive. But Power BI is free, Excel is free, and so for cost reason, we may choose the other ones. Yes. Tableau is also visualization. Excel, you can analyze with it, you can also do visuals. Plotting with Excel. Do you get that? So now we have programming-based data analysis softwares. We have Python, we have R, we have so many of them. Those are just a few. Julian. At the top of the list, we have R and Python competing. You get that? Which one you should go for? This is my personal preference. It doesn't mean that you must go for it. You can choose between whatever you learn. But the truth is that once you learn one, you can always easily learn the other. Do you get it? So for me, I prefer Python. Python is more versatile. You can use Python for web development. You can use Python for artificial intelligence, machine learning. You can use Python for Internet of Things. And then you can use Python for data analysis. But if you want to limit yourself to data analysis and data analysis only, then R should be more ideal. R was built strictly for data analysis. And one thing with Python and R is that they have large communities. So people keep bringing in plugins. Plugins are a kind of libraries to help you do certain things. You want to calculate mean. Yes, normally you're supposed to write a very long code to do it, but somebody else gets it, and so you just have to come and put your data and get the mean. You get that. So you want to take a software that has a large community because they will keep modifying the software and making it easier. You have a challenge, you go and search online, you can always find any person who will provide support. So R and Python, you can choose in between them. But this one needs a bit of programming languages. Non-programming languages, we have SPSS, JABs, Stata. Stata has a bit of programming, Minitab, and so on. There's so many of them. You can choose one of these. But for us, we'll be using SPSS. We may look at the interface of JABs, maybe in a single class to see. But the truth is that if you use SPSS and you want to use JABs, you don't need maybe further training. What's the advantage of taking maybe SPS? JABs, SPS is costly as well. Although you can always get maybe you can get free versions, right? But with limited options. But the program like JABs is open source. Open source applications that are free, which may everybody you don't pay a dime. R and Python, they are free. So you don't need to pay anybody, just install them in your machine. The latest version you install, nobody asks you anything. So it's JABs. Stata, you need to pay. Minitab, you need to pay. But in our class, our interest will be Excel, SPSS. We'll say we'll take maybe one class. Remind me if we are getting out without looking at maybe JABs. I like JABs because it's quite user-friendly. The interface and the way tables are presented is more friendly as compared to SPSS. Do we get that? But we are in this class, we may put emphasis in X more than we used to do before, given the industry demand, the request. So that's the thing. So if you want to become a data analyst, and so this list is not completed because I've not seen database applications. We need database applications, right? We need to learn at least one database. We can learn Access. We can learn MySQL, which is very good. We have ProSQL, and there's so many of them. You choose one, right? Ones they call MongoDB and the rest. Now, these softwares in themselves, they don't make you a data analyst if you don't understand what you need to do, right? So as many as they are, 80% of the work, the Pareto's principle they say, holds here. 80% of your analysis will be done by 20% of this application, right? So you don't need all these applications to do 80%. Just 80% will be done by one or two applications. So you don't need all of them. If you understand SPSS to your fingertips, you can analyze most of the data. You can analyze most. There are a few things, especially you can do. But then it's good you know as many as you can. But don't think that learning many can make you a data analyst when you don't understand what data analysis is. So that's just, so don't go learning everything. Rather learn the key aspects that we have said, which has to do with inspecting data, cleaning data, transforming data, analyzing, and reporting. That is your job description. Right? That's your job description. Any other thing might be secondary. Any question with respect to this? Yes. Power BI. PowerPoint is for presentation. This slide is we're using a PowerPoint. But Power BI is a data visualization, which means you put data, you analyze the data. You understand? But all of them are Microsoft applications. So with PowerPoint, when you have done everything, you can now come to PowerPoint to put it there and project for people to see. It's presentation. The main purpose of PowerPoint is presentation and designing, like we saw when we are doing our designing program, right? Yes, it's for designing. But Power BI is for data analysis, especially using what? Figures. You get it? Yes. That's the main difference. So you can analyze the data, everything is text, but you want to have pictures. If you see graphs going up and you see the tallest, you already know that's the one with the highest, right? So that is the essence of what? Visuals. And visuals play an integral part in the reporting of results. Yes, we can read text, but when you bring a picture, it helps us better. You get it? So that is the key thing. Yeah. Power BI. I'm saying that Power Tableau, Power BI, Excel, Looker, right? Yeah. Functionality. Maybe I don't really. Okay, what we said was, let me repeat what I've said with respect to Power BI. Power BI is used for data visualization. That's the key focus. You want to present your data using charts or whatever type of plots you can do them in Power BI. You want to build a dashboard, you can do it in Power BI. And you can do the same for Tableau. You can even do it for Excel, as we'll see. You get it? But I want to say that the difference between Excel and Power BI will be that Excel is an advanced, it's an upgraded version of what? Excel. Because Power BI will take more data, more columns, more rows as compared to Excel, right? Actually, Power BI is business intelligence. The BI stands for what? Business intelligence. All of these applications, for instance, Tableau and Power BI, they are considered as what? Business intelligence application. BI stands for business intelligence. So they are used to analyze data for business decision making. Now, somebody who learns all of this, if you take your time and learn Power BI and Tableau very well, or just Tableau, one of these, you can call yourself a data analyst. Because you'll be able to analyze and present data. You'll still be able to do a lot of things, but whatever you be doing, we're dealing more of visuals, right? You may not be having things like mean easily and the rest, because they're not adapted for that. You will get the difference. Yes, you also need spreadsheets. Okay, all of this can consider to an extent spreadsheets, rows and columns, but I want to add to this list Google Sheets and Excel. They're very vital. If you learn Google Sheets, fine. If you learn Excel, all of spreadsheets, they function almost the same with slight modifications. You get it? Yes. There are lots of billing, artificial intelligence. So, any question from those online? No question. I believe we are good to go. So,
Liz, I have a question to ask.
Yes.
What's the difference between these auto-managed tools? For instance, you have something like Excel and SPSS.
Excel and SPSS. Okay.
Yes.
One, if you look at Excel, as we said, these are programs. If you want to plot your data with Excel, right? Once you highlight your data, you just take maybe insert. You see that they have a kind of a lot of intelligence to automatically do some of these things on their own. But then the major difference is SPSS is data-driven application. That's the main thing it does. All right. Excel, if we're learning Excel for data analysis, will be different from learning this Excel for accounting purposes. Will be different learning Excel just to maybe input your data. Do you get it? Because you may need to go and add some add-ons or ins to be able to for it to function differently. However, we all said all of these programs will share something in common, that they analyze data. You get it? The interfaces may be different. For instance, the interface of Excel and SPSS, they look similar, but there are some differences, significant differences. I hope the point is clear.
Yeah, it's clear.
Yes. So now, like we said, the work of a data analyst starts from data extraction. And we say it could be extracting it from questionnaires people are collected, or even from collecting, right? You have to extract data from the source, could be from a database, from the company records, from whatsoever your data is. Once you extract the data, you have to clean the data. Cleaning and wrangling, to me, they're the same thing, but wrangling here has to do with transforming the data. Maybe we mentioned yesterday, if you collected data from different countries using different currencies, you need to transform to a uniform. That's part of data wrangling. You take data from different sources, you may want to combine the data. You may want to combine financial reports with customer information, with human resource data to be able to make decisions. You get that? That's the work that you have to do. Then data exploration and analysis. Data exploration and analysis, like I said yesterday, which we'll see, you explore data to understand the data, right? That's why we have data exploration, which just help you to understand your data, and then data analysis and explanation. Data explanation now is for decision making. I take my data, clean it, and I want to see if there are outliers in the data. I'm exploring. That one really has not much to do with those who will be making the decision. If I want to verify if my data meets some assumptions for me to use a particular technique, you are exploring the data. Because before I use regression, I need to check all the necessary assumptions that pertain to regression. You are exploring the data to see if the data fits. And once you have done that, you should be able to now take a decision that, okay, I will analyze the data based on this technique, because the data, if my data is categorical, this is what I can use. If my data is categorical with this number of, this is the possible analysis that we do. So you are exploring the data to see how to. Now, action has to do with reporting, right? The aspect of action has to do with reporting, to be able to, after analyzing the data, what are the recommendations? What should be done? What should not be done? Those are critical aspects for us to understand. So that is a process. It still goes back to collaborate with our initial definition, right, of data analysis. It's a process. Any question? Any worry with respect to what we've done? So we are done with the first key concept, understanding data and information, the differences. We've talked about the different applications. We've talked about the different tools that are useful or we can use, and we have emphasized that 80% of the work will be done by what? 20% of the tools, right? So you need to understand that. So, yes. That's part of the process, data transformation and normalization. Yes. Yes. Brian, you seem to have a question. Okay. Just for a purpose of exercise. Yes.
Morning, is there?
Yeah, come again. Maybe it's...
You said, I said no. You said any questions, and I said not really, sir. I'm following up.
Okay, no question, right?
Yeah, so far so good. So far so good.
Okay. So, what's the difference between data and information? I think that's okay. We don't need to go back to that. Elaborated on that. You can go and read it. If example of data and information, I think we've said a lot about that when we process. And so, let's take that's our first key concept that we need to understand. Now, next concept that is important as a data analyst or a researcher is population and sampling. We will not take too much time here, though we used to take a lot of time, but we go vividly. So, what's population? What's sampling? No, we have been doing all of this in our school, in our practice. And I know you will be wondering why we want to know what the population that we already learned in school. Where's population? You can read and give me a definition. I'm having... Yes. Yes. Mm-hmm.
Because generally, a problem is usually right. I can say right. So, any more contextually, the audience here, depending on how large the group is, what the context that population. And usually, it can be very cumbersome to carry out the assessment. Higher audience which is considered. So this is where something can have to select particular subset studies.
Okay. It says when we talk about population, we're referring to the entire audience. So access with that. I would disagree, so have something to add. I have a definition which says population is any specific collection of objects of interest. And so in this definition, key things is object of interest. Do you want to carry out a study? Each study has what? A subset, has where data will be collected, right? If we're looking at financial information or we have maybe time frame or whatever we want to consider. So it becomes objects of interest where our data will get our data from and our findings will be applicable to. That forms our what? A population. And in this case, every member of that group forms the population. Now, in other words, population refers to a collection of objects of interest to which our study is based. Two studies, the same topic might have different population. It could be in terms of geographical location. It could be in terms of maybe the aspect of, for instance, geographical location. I want to consider maybe just those in the Northwest. It would be a specific geographical location. And somebody collecting on the same study by using Cameroon, the population will be different, right? Somebody collecting on the same study may say, I want to use those above 50 years of age. So those above 50 years of age become what? Objects of interest. Somebody collecting maybe wants to study by animals. They want to study by things. So it's not less human beings that form population. It will be things that we want to collect data from. You want to see the prevalence of a particular disease in certain animals. So the animals become object of interest. Now, in application, it's always difficult to collect data from all the members of interest. It's always difficult. Assume that you wanted to collect data from everybody in the Northwest and Southwest for your master's thesis or your BSc thesis. God forbid. Everybody need to go to, how do we call it now? Bakassi, from Bakassi to Fulawa to all those places, because very difficult, right? Very costly. And in some cases, practically impossible. Very difficult, costly, and in some cases, practically impossible. Do we get that? And so, because of this challenge, and because of other reasons which statisticians have derived, they tend to select a subset. That subset is considered what? A sample. We know these things. We're doing revision, right? It's a sample. So what is a sample? A sample simply means a subset of the entire population. You've selected some groups or persons or things to represent the population, because it might not be economically reasonable for you to collect data from everybody. It might not be possible because of some things beyond your control. Time might not be on your side, and so on. You decide to take a subset. And so researchers use most of the time a subset. In a situation where you collect the data from everybody, we call it census. If you successfully collect data from everybody, then it's a census. So if you're making a study and your target population was about 50, maybe 50 persons, and you take all of them, then you did not have a sample, you have a census, but everybody was included. You said the government collects the census. Most often when you say government wants to do the census, you don't say take samples, because the government is taking everybody. The government tries as much as possible. The last census in Cameroon was 2005. It's very costly to do it. So 20 years down the lane, nothing has been done. They only work now on estimate projections, right? So that is that. So if we talk about sample, then we have different sampling techniques. And this is an interesting part when it comes to population and sampling.
Thank you, Val.
The decision to take on a sample is critical to a researcher. The sampling technique you adopt is critical to give you the outcome that you want. Do we get that? The sampling technique. So there are different sampling techniques that we have, but we generally divide the sampling, which are the approaches for you to collect the data from this selected group of persons, into two: probability and non-probability sampling. With the probability sampling, which is more quantitative driven, which means, quantitative data driven, the idea is that we try as much as possible to give an equal proportion to participate in the study for everybody. The chances of selecting are almost equal for everybody. I'm using the word almost equal, right? Yes. So if you select A and you select B, the chances of selecting the two persons are the same. That's the idea of probability sampling. So your participation is based on a certain probability that will be attached to you to participate in the study. Now, under probability sampling, we have principally about 4 types. We have the random sampling, we have the systematic, we have the stratified, and we have the cluster. Those are the key. There might be more, but we have the 4. The random gives every individual equal chance to participate. The participation of A doesn't prevent B from participating because of maybe an underlying attribute. I always give a simple example. The example might not be real, but I always think that American lottery, it does maybe all lottery games they tend to use what we call random sampling if what they promise, what they do, right? Once you play a lottery game, what happens is that your chance of winning is probabilistic. It's based on a certain probability. If I apply for American lottery and you apply for American lottery, whether you are taken or not, it's not correlated. If we come from the same home, they can still, all of us, we can win, right? Yes, not because you come from the same home that once A has been taken, it will prevent me. And so two persons can be taken from the same home and you go to another home and even a whole community, nobody's taken. It's just by chance. You get it? There's no underlying preference to A or B. It's not because A was too educated that was chosen, no. That is random, simple random sampling approach. Now, this one is more difficult to be attained in real world because you need a sampling frame. You need to be able to assign. For instance, what American lottery does, that's my assumption, is that when you apply, they automatically assign a code to your unique identification number. And so when it's time to select, they say, okay, the machine pick up these numbers. So they just pick the numbers. They don't attach to names or whatsoever. They take those numbers. Maybe they come now and align the names to this, they align them. Okay, based on this code, it was this person, right? Your name was, every information about you was taken away. They only rely on the code to come back. So it's purely by chance. So you're taking, you don't know. One way that people do random sampling, for instance, you want to go and collect data in a school, in maybe secondary schools, and you choose as random which schools to go to. There are 100 schools. So you can put the names of the schools in a basket, and maybe you say, college, let the child to come and just pick out maybe 5 schools. And so any of the schools the child pick, you go to. So which school was selected was purely what? Probabilistic. That's simple random. Now we have systematic. With systematic sampling, yes, it's still probabilistic, but we have arranged it in such a way that participation depends to an extent on a certain maybe formula that we have established. Now let's go back to American lottery example. Now we have said, okay, let's divide. We have assigned codes. Maybe the codes were numbers from 1 to 50,000 persons that applied. And we say the way we will select the 5,000 persons to go to America for this year is that we'll start from any number, but we count 1 to 3 up to 5, and we take another person. 1 to 3. So we take 5, maybe we take 6, we take 11, we take 16, and so on and so forth. In that order. So there's a systematic arrangement of how we collect persons. Whoever we take at the 5th position or the 11th position or whatever position was totally still based on what chance, right? Yes, but there's a systematic way of selecting persons. Do you get that? So that is the idea. Then we have the stratified sampling approach. With stratified sampling approach, what happens is that researchers identify an underlying attribute in the population that can influence the outcome and divide the population into different strata, right, to select participants that covers everybody, all the different underlying interests. For instance, you want to collect information about COVID-19 in the Northwest and Southwest or in Cameroon. And the rate of prevalence or the possibility of being infected. That's one thing, right? So in order to collect that data, you may discover that each plays a role. And so it's try to divide your population now into maybe the young, the adults, and the old. And make sure that you collect persons from the young, the adult group, and the old. Do you get that? So there is what? An underlying element that cuts across, but that differentiates the participants. Although they come from the same group, but there's something that makes them different, such that results coming from one group may be different. If you just take the young, maybe you discover that COVID has no problem, so you move on. But then it gets to an older population, maybe they become more vulnerable. So there is an underlying interest, something that cuts across the entire population that differentiates the populations. that you think that may influence your results. And so if you take results from one set, it might be biased. So you have to use a different stratification. And lastly, under that, we have the cluster. With the clustered approach, basically, you still divide your population into groups. But then, in the first case, what we did was that we took everybody across the different groups, right? But the second one now, we take a single group to represent us. Now, I want to study the prevalence of malaria. I don't know why I'm talking about prevalence a lot, as if I'm come from the health domain, but that is not my domain, right? In Cameroon. And so you decide to take one region to represent. Geography most often can play a role. You take a single region. So once you go to a region, you include everybody. That's clustered sampling method. Once you have studied everything about the region, you can, and you do that because you believe that the regions are a replica of what? The whole country. But if there are underlying differences, using this approach will give you wrong results. You get that? So you can use a single segment and generalize if there is a uniform population. And it brings us now to a critical point to take note. When you are selecting a population, it means they are identical. They share something in common for your statistics and your analysis to be valid. Such that a sample for qualitative or the probability studies is what? A representation of the population. Because the results you get from the sample will be generalized to the population. I always say the sample's results are not relevant. It's what will be done to the population that is of importance. Right? When you go and take data, for instance, for those who have collected data, when you go and collect data from 100 women in the farm or in the field, at the end of the day, do you have anything to do with the 100 women? It really has nothing to do. It's that the opinions of the 100 women will help you to do something with respect to 1,000 women. You get it? So the sample, although it's important, it's not really our prime focus. It is the end results that we want to get that we are focusing on. Are we okay? So that is something worthy of note for us. Now, having said that, apart from the reasons we have given, why we may not be able to collect data from everybody, there is something in statistics called the central limit theory, which we will later see. That says that if I take an entire population and randomly divide the population into different sections or segments, then the statistics, for instance, the mean of the sample will be approximately equal to the mean of the population, given a certain degree of confidence. Don't be frightened by this one, right? God will be using them. If I take the central limit theory says, so that, okay, let's assume that we were an entire population, the class, right? So we divide our class into 4 groups. Then the mean of the average for one group, whatever we are trying to get, will be approximately equal to the average of the other group, approximately equal to the average of the entire group put together. And so it's based on that ideology that we can use sample to approximate what will happen given a certain confidence interval. That's why most often we are presenting results, we always talk about confidence interval, because the range of values that you believe that the population mean falls within. Do we get that? So that's the first thing that we need to underscore. Apart from the cost that is involved, the time and the inability to collect from everybody, we can now use results from a sample to generalize the population, because if it is data, if the sample represents the population, then the statistics or the analysis that we get from the sample can represent. So the 10 women that you use gives you information valid enough to generalize to the 1,000 women that are constitute your entire population. That is a reasoning in statistics. It has been proven to be statistically valid. That's why they apply it. So thus far, probability sampling is very ideal for quantitative studies. Although in application, we still use non-probability studies, sampling techniques for qualitative studies and for quantitative. So for the non-probability, it means participants are not given equal chance to participate in the study. There are different factors that influence why somebody should participate in the study. There are different elements that influence our sample. Do we get that? So in terms of the types, we have the snowball, we have the quarter, we have the convenience, and the purposive. The snowball. With the snowball approach of sampling, it is a sampling strategy used when the researcher doesn't have an entire knowledge about the population. Let's assume they wanted to study now Amber, ex-combatant or whatsoever you may want to call them, or you want to study abortion or HIV patients. Those are sensitive topics, and it's difficult to see people that come and identify themselves as HIV patients, after abortions, and this and that, right? So it becomes difficult. The approach you adopt is that you may get one person, after working with the person can recommend the other person, this and that. For instance, it's easier for an ex-convict, or let me say, to identify somebody I was with, to go and talk to this person. So we call it a referral method, right? We have the quarter, which is just deciding that after collecting data for 1,000 people, you think that the data is okay for you to go and analyze this. It's judgmental. The next is judgmental. You take decision based on you, the researcher that believes that. All of them have their disadvantages. We're not going into that. We're doing variation, right? And it's not a focus, but it's important because your analysis will be as valid as your sample and valid as the population. You cannot consider all women, and when you are done with your studies, you conclude with respect to young girls or adults. That's why we're saying this. So we have convenience. Participation is based on ease. I want to study something, I just look for those who are available and ready to participate in the studies, convenience sampling. So it doesn't give everybody the chance to participate. And then we purposive, key informants. Especially we hear those who collect data using qualitative, like interview, keep using the word key informant, key informant. Why are they key informant? They either have experienced a situation, they're very knowledgeable, right? So there's a particular criteria that you include somebody. It could be that the person has the experience or the person has the knowledge to be able to give you the authentic information or data, provide authentic data. Remember, the person provides the data, not information. Do we get that? That's why the person is considered a key informant. Then your participation is based on either you, okay, let's say you're studying the crisis and you want to see, examine the effect of the crisis, and you're very much interested, you may want to get somebody who have either who was in somebody killed, who now have an experience, or somebody who has studied crisis who will be able to inform you on maybe the consequence of a crisis. This is a key informant based on knowledge or based on experience or any other criteria that you want. Do we get that? So those are the key sampling techniques, and they're very, very vital when you want to design your study. That's why we talk about research design. When you are talking about your research design, is it survey? Is it experimental? Is it? And so these things, they all play a role. We all want to be academically driven in our studies, because even from those who are here, they are more industrial driven. So otherwise, we have been talking about the different types of research design in depth, right? Their codes, their procedures, but then we want to focus more towards analytics, which is the industry data analysis type. So now, having discussed population, having talked about the different sampling techniques, it is important to take note that researchers must at times might not be biased, either in their design or in their data collection approach or in their sampling approach. So you must take into account to make sure you avoid bias. This is what we call bias and not as a researcher, right? So there are different types of bias. We have observation bias, observational bias. You see something that seems to be, you look at red and you look at white and cream white, you just consider it's white. It's observation bias. You get it? Yes. Or you basically want to confirm what you already experienced. Yes. Yes. Yes, it's something, it's a key concept that we'll see along the line. Confidence interval, the significant levels, and the rest. Yes, we'll see. That's why I see some of these terms, there are so many terms I'm using, we'll familiarize ourselves when we are done with that outline or when we'll be doing the practical. Yes, we'll see. So, we've seen that there are different types of biases in the research that we can make, right? We have expectation bias, selection bias, voluntary response bias, confirmation bias. And we're not going into that. What happens is that bias tends to skew the results. It makes the results come from maybe, for instance, let's take the case of confirmation bias. And this occurs when the researcher already have a pre-expectation and you go to look more or less to confirm what you already have in mind. You are going to meet somebody to pay you money and you already know that the person will not pay. And you get that the person doesn't pay. And the example might not be scientific, but that is to contextualize what we're trying to say. It's confirmation bias. And I'll give an example, especially with political polls. We get the follow American election. CNN goes to look for people who decide to say Trump is a bad presidential candidate. That's actually who they were looking for. They only wanted to confirm their results. Now you want to collect data about homosexualism and the rest, and maybe you have a negative perspective about homosexualism, and you go and look for those who Christians, obviously, and then Christians who we know they already have some, right? Come and say most of the people they refuse that homosexualism is bad, abortion is bad, because you are looking for a particular group of persons, or you collected people with maybe it may not necessarily be confirmation bias, but what? Observation bias. You get that? And then you went and got persons who had a particular view with respect to what you are looking for. So, as a researcher, you need to ensure that your data is free from bias as much as possible. Apart from bias, we also have what we call noise in data. Anybody who has an idea what noise is? Noise in data means, I'll try to explain what noise is with an example. Let's assume that somebody was accused to have stolen, right? And so we take the case to the court. Court A, we have two courts, Court A and Court B. Court A is not aware of the results of Court B. They're working independent. After examining the case and the evidence that we have presented, or the person presented, Court A says this person is not a thief. You go to Court B, examining the same events or the same evidence, Court B says the person is guilty. Something is wrong. All right. So basically, noise in data means while we expect that our data should give the same results, it tends to conflict and give maybe contradictory outcomes. If the judges were all experts, why give us different results to the same case? Because as expert, we expect they should give us the same. You get it? It's different from bias in that bias is tilted towards a particular opinion. But let's assume that we had not only two, we had up to 5 or 6 different courts. 4 courts, says the person is guilty, or 3 says the person is guilty, 2 or 3 says the person is not guilty. And we're like, wait, we expect that the results should be unanimous. But we can't find why they are giving us different conclusions. to the same case, the same evidence provided under the same circumstances. Do you get that? So there are some things that may skew your results not to be valid or not to reflect that the conclusions that you get might not get the expected outcome. Out of this, if you take away bias and your data was collected using and you did your sampling well, your results, what conclusion that comes from your data analyzed using the right techniques should reflect the reality of what is on ground, should be able to affect the entire population because your sample was ideal, your data was ideal, and everything was done accordingly. If you say most people will like this new innovation in our product, then at the end of the day, people should like it. Do we get that? So, any question? Any worry? The noise is that we expect that they should give, it's like, okay, let's put it another way. I give you the same data, I give you the same data, I give you the same, all of us here, we share the same data. We analyze the data, we give different recommendations. Using it, we say use this particular method, analyze this data, we're giving you the same data. By the end of the day, the conclusions and recommendations are different. Right? No, but under normal circumstances, we should have a uniform conclusion. That's why I say a data analyst in Cameroon is not different from a data analyst in America. If you have done your analysis and you understand the principle, they give you the same data. So the results should be the same. You get it? When we start seeing conflicting results, then there is noise. We may need to find out where the source of the problem is coming from. You get it? So that is where the idea about noise. It's different pattern. When we get to analysis, part of data cleaning and evaluation. Part of data cleaning. These are the concepts. Now we're talking about concepts here. That's why there's a lot of theory. Some of those things do come up. Data and different conclusions. Yes. 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 So now, without any question again, how can we handle noise? Our sample, I mean the bias and the noise, our sample should be what? A representation of the population. We should take care of data saturation, those are some ways, and randomness. Randomness simply means, especially with data collection, let's give an example of another situation that you may discover that results may vary. And this one has to do with the aspect of randomness. Now, when I was in primary school, class 1, class 2, I don't know which class you were, but I believe you attended that class. Conditions for seed germination or a plant. What did they say were the conditions? Nature studies. A good seed. There should be water. There should be moisture. There should be sunlight, right? Environmental condition. Let's say soil. Let's consider it to be soil. What again? You did not attend the class. Sir. Okay. You were not in that class. The class that we were taught condition for seed germination or the growth of plant. Now, based on that, when you are collecting data and you single out your variables, you need to control for the rest of the variables. We'll talk about variables in jiffy. You need to control for other variables. For instance, let's assume that we wanted to test whether a particular fertilizer affects the growth of a crop, because fertilizer is one of these things. Now, what happens is that we are doing an experimental study. We go and create one farmland, and we apply fertilizer. We create the other one. We don't apply fertilizer, but the farmland. And so our expectation is that the fertilizer helps the crops to do well. That's our expectation, right? That's our hypothesis. So at the end of the day, after cultivating the farmland for 9 months or 3 months, if it was tomato 3 months, and we discovered that the produce from the farmland with fertilizer was less than that for that with that. Oh, our hypothesis has failed. But what is responsible? We need to go and dig out the other factors that might have changed the results. It could be that the two soils were not the same. The one that had did not have fertilizer was more fertile and more had everything intact than compared to the one that we went and applied fertilizer. It could be that one was more exposed to sun than the other. So what researchers they do is that they try to harmonize the rest of the factors. The soil should be the same, the fertility of the land should be the same, exposure to sunlight should be the same, right? In the case of this farm that we are trying to build, if you are collecting data in the field, you need to, or you are trying to do an experiment, you need to check all the control factors. What are those things that can influence your dependent variable to control for them, to manage them, to make sure that they're all the same, to hold them constant, right? In economy, you always say you hold other factors constant, right? It means that the factors are not influencing your resource. That's the principle. So that's the idea. So you must ensure that that is what we call randomness. You want to make sure that everything is equal. Do you get that? Any question? Anyone? Data saturation. Yes, data saturation is an aspect in qualitative research is broad. So there are so many terms that you need to get. Data saturation, let's assume that you want to collect data and you are using qualitative instruments. Now, the opinions that you get from 10 persons, if you go for 50 persons, you might not have a significant difference. More using the word significant difference from what 10 persons have already provided. So it's not worthy going to collect data for 50 persons when what the 10 provided was enough from the same population. So data saturation. That's why qualitative studies, the idea, their motivation is not a large data set, but that the data provided by a few should be a representation of the views of the general. So we're not saying that go now collect maybe 1,000, at least 5,000 persons or 100 people so that you'll be able to work qualitative data. We are looking at those key attributes that prevail that affects the entire population. Once you start bringing, after the 10 person, when you start bringing in the 12, the 4th person, they're not adding anything new. They're only repeating what maybe others have already provided. They're only adding, repeating, maybe in different words, but the same thing. So that is data saturation. Like we said, when you are doing data analysis, there are some key things. We talk about bias, we talk about sample should be representation, we talk about data saturation and randomness. As things that you should consider when you are doing data analysis and sampling, or population and sampling.
So yes, trying to say that randomness here under this condition is like different from the randomness. It's the same concept. For example, talk about
randomness is saturation.
No, I mean randomness ensuring that the control variables
is the same. That's the basic idea. You're trying to control for other variables that are influencing your results, or at least take factor in their contribution. You get it? When you go to analytical techniques, we talk about mediators and the rest, and control confounders. Most of them, they will call them confounders or confounders. I will see. They influence our results. At times we capture the effect. At times we don't. But we need to know that they are there. Right? Yes. With probability studies. Techniques as. Yes, they take into account. Yes, it's the same thing. It's the same thing. We're saying that for the probability, right? Don't go and take only from beyond to represent. Take across. That's ensuring that it should be randomness, because that age factor or maybe educational factor had something to do, right? Especially demographic factor. That's why most often when you collect data, you take demographic factor because they have a tendency to influence Whoever is talking is important. Who is condemn abortion is important. It's a Christian. It's a he or a she. Is a person young or old. You get that? That's why you collect that information, because you need to correlate how those the age will influence the person's view with respect to abortion or not. Do you get that? So, is it time for break? Oh, we need to take a break. Let's take a break. So we need to take a short break, about 10 minutes to come back. Let's regain our energy to come back and continue our class. 10 minutes, just online. We are resuming in 10 minutes. Okay, we just do not, when it's break time, nobody sits in class. We all go outside. So that the class will have air, while we also get air outside. Right? Sitting for 3 hours to learn is a bit. Okay, enjoy the break. Okay. Welcome back. So, we have a long way to go, so time is not wasted. At least there's some exercises. I believe we can do that. Try to answer all the questions on our own. So we'll take the next concept, which is important. Pardon. No, you can answer on your own. Just to help you secure yourself in respect to what has been covered. So, what's the variable? To put it simply, if I'm looking at the definition from a slide, a variable is defined as an attribute or a characteristic of the participant or a situation in a study that has a tendency to take on different values. It means it has the possibility to vary with different varying outcomes, depending on what condition. A good example to understand would be gender. If you're looking at gender, immediately use the word gender in the context of Cameroon, we'll be thinking of male or female, right? Although in some countries now the situation has changed. So we have gender, when you say age, you think of your own age and you think of your age group and so on. That's what a variable is. Now, looking at that, in a research, we most often have two key variables, which are known as the dependent and independent variable. The dependent variable is the outcome variable, the variable that we intend to see how it changes because of the changes we're making to the independent variable. We set factors influencing the growth of plants. If you look at that as a research topic, we may name water, disease, and that those are independent variables, right? Then the growth of plant, which means how plant grows depends on those factors that were enlisted. So that is what we say a variable. Now, the variable that is independent, like we use the word dependent, or the presumed cost is an independent variable. So what we do in a research is that we always have to manipulate which one is the dependent, which one is the independent, because it's not fixed. In one study, a variable that was treated as independent can become independent in another, right? Yeah, so when, for instance, if you're doing an academic study, you always discover that we say, where's the dependent, where's the independent? And most of the times you collect data to come and manipulate and see how changing, for instance, if I take only women, what would be the performance of the company, maybe measured in terms of output for a particular month. If I take only men, what would be? And is there any significant difference in the performance with respect to men and women? So using the different categories of our independent variable, which is gender and output, means we are manipulating. You get it? We're trying to change the different levels of our independent variable and see what happens on the dependent variable. If the company increases sales by 5%, or maybe prices by 5%, what happens to sales? Will it increase? And what will be the increase? Will it reduce? And what will be the reduction? And if there's a reduction, how is that related to profits? We have to analyze that. So price is our independent variable. Sales is our dependent variable, because how much you sell will depend on the price, right? If you make sense, it's not just price, but just for sales by profits. And how much profits you make may depend on the price you are charging. So you have to evaluate that. So the value, the dependent variable is always the outcome variable. Some call it the criterion variable, and so on and so forth. And the independent variable on its part can be called the control, maybe an input variable. We can call it a predictor, as we see in others, and so many other factors. Yeah. In some studies, you see they call factors, some call predictors, some call inputs, some call independent variable. All of those, they mean the same thing. Now, apart from dependent and independent variables, as we've seen, which we are manipulating to see the different conditions, like we say condition A and B, we equally have what we call external variables. And external variables are variables that have a potential to influence our dependent variable. So they're actually independent variables, but the researcher is not studying them. You don't consider them. You are not manipulating them in your study. For instance, we have said, still going back to the case of rainfall and the rest, soil, we said to use water or fertilizer and ignore water and the rest. Those are external variables, right? They also affect our independent variable. We're not measuring the effect on the dependent variable on the growth of plant. So they influence our outcome variable, but we're not studying them. They're not of particular interest for us. And that's where we say we need to try to make sure that they're equally by doing a control study. Now, apart from that, we also have, still in the same category, we have what we call mediators. Now, these ones are for advanced analytical techniques, but it's just good to get them. Mediators are also independent variables, but that they transmit the effect of the independent variable to the dependent variable. In other words, if we take away the mediator, we might not have any influence of the independent variable on the dependent variable. For instance, we want to, you're teaching in a class, students are participating in a class, some are copying notes as a common example, and others are not copying notes. And so you want to study the effect of not copying and on academic performance, right? Copying notes is not enough until the student reads the notes, right? So reading becomes what? A mediator, because it can either improve the effect of dependent variable on the dependent, on the independent variable on the dependent, or you can prevent that from. So if I copy notes and I don't read, and you don't have notes to read, at the end of the day, our performance cannot be differentiated because of note taking. So there is that intermediate variable that transmits the effect. Now, in a situation where the mediator does not completely eradicate, without the mediator, we still have the effect of independent variable on the dependent variable, then we may call that a partial mediation, right? Which means not taking just partial, it plays just a partial role on academic performance, right? Reading just plays a partial role on academic performance. Rather, without reading, once you are taking notes, it can affect the performance. That's partial mediation. Full mediation is when, without note taking, academic note taking, without reading, note taking has no effect on academic performance. That's full mediation. But like I said, this is for advanced analysis. So we'll not see the application of these variables. But we know them. The next set of variables for us to see are the moderators and the confounders. Now, a moderator is an independent variable that gives different effect on a dependent variable depending on what level of mediator we are. Might seem a bit confusing, but let me use an example that we've already talked on. Let's take the case of evaluating the effect of gender on performance, right? The effect of gender on performance. If we check and see that the effect of gender on performance varies, then gender is kind of a moderator if it changes the nature of the relationship or the effect. And if that example is not very explicit, the output of women completely different from that of men, right? So gender is a moderator in that case. But if the output of women same to that of women, even then it's not a moderator. That explains why, when it comes to some professions, maybe pay depends on gender. Take the case of Man Common Race of Hope. We discovered that during Man Common Race of Hope, we see that there's a division between men and women. Have you ever considered why they do so? It's because the level of performance, the level of running, or distance running and resistance depends on your gender. Men will take 4 hours to come, but the first female will take 4 hours, 30 minutes, and maybe they pay the same. Why is the difference? It's because statistically, gender affects or performance or running depends on the gender. It has been proven as such. But when you go to an academic setting, for instance, it doesn't really matter. That's why we will not say women should be studying in a different classroom and men in a different, we'll put them in the same classroom, because there's no statistical evidence to show that men perform better than women or women perform less than men when put in the same classroom. But when it comes to running, we separate them because though we have different results. You get them. So those are moderators. And so when you want to take a decision, that those factors are there, you must also always consider. If men are performing more than women in a company, and you don't think that the other factors that influence pay, then you might be obliged to pay men more than women, and vice versa. You get that. So that is a moderator. And lastly, we have the type of variables, we call them confounders. And confounders are variables that There seems to play a trick in our results. I don't know. Of which, if we don't take care, there will be wrong conclusion. For instance, if you look from our slides, we are talking about alcohol use or alcohol, that's drinking, and lung cancer. Now, there's a close relationship between smoking and drinking. So that the people who smoke, they drink, and the people who drink smoke, right? So somebody with lung cancer comes in and the doctor checks the person and says, you have lung cancer. And that this lung cancer has been aggravated by drinking, right? In reality, it might not be drinking. It's irresponsible. It's that the person is smoking. But because there's a close relationship between smoking and drinking, there's a tendency to draw wrong conclusion, right? Those are confounders. There are variables, independent variables that has a tendency to help or influence our results. We can draw wrong conclusions because we do not take into account the presence. It still goes back to that aspect of controlling, like we said, noise. Those are some things that we can play a role, and our conclusions are wrong because of the presence of such variables in a study. You get that? So the doctor was saying, don't stop drinking, which the right thing would have been stop smoking. Do you get that? Yes, so those are the key variables that we have. We've talked about dependent variable, we talk about independent variable, we talk about externals, which are all of the rest of the variables we have mentioned, and just consider external variables, mediators, vectors, and confounders. Now, the work of a researcher principally, or a data analyst principally, is manipulating variables, nothing else. Nothing else. It's just seeing how one variable affects another, how the relationship between one variable and another, and that's all what you do. Principally, that's what you do. And once you collect data, each question in your variable, in your questionnaire, for your questionnaire stands for a variable. We may have composite variables, which is a combination of maybe a set of questions, like what we do with strongly linked item questions, right? To create composite. Composite simply means a combination of one or more different things to give one outcome, right? But what is important to note is that we have a list of variables that each question is a variable. That's what is important. So gender on your questionnaire is a variable, age is a variable, and whatever research question-based sub-question you're asking that are targeting a particular research objective, they constitute independent variables. All of them should converge to measure your outcome variable. All of them should be able to converge to be able to capture your problem that you are out to study. So that's all the work of a data analyst, trying to see how one variable affects another or how they are related. So variable is a normal daily balance. Whether you are doing computer programming, you hear variables, right? You hear variables. Yes. It's the basic tools that you use. It's the same concept here. It's the same concept. It's not different. But that this one is linked more or less to data. When we are writing programs, we also start with a variable. Now they will give us different types of variables, logic, and the rest in the computer. But it's the same reasoning. It's a true or false, yes or no, binary, continuous, as we see as we progress. Any question with respect to variables?
This concerning confounders means that this one is usually assumption by the researcher.
It's not only that you're assuming, it's that you need to be aware of their presence, right? Yes, you need to be aware that they are there so that you can take into account directly or indirectly to either neutralize their influence on your dependent variable. Yes. Because if their role dominates your independent variable's role, then you will not see, you will discover that you can be drawing conclusion that it's not real. So they're always kind of, you have to control for them. Those variables that are there that you might not. Don't say someone should stop. For instance, you say someone should stop smoking. I mean drinking. But it's not drinking that's a problem. And the person stops drinking and continues to smoke. You've not solved the problem, right? Yes, because the conclusion was based on. But it's because of that close relationship exists between the two that you did not take into account. That your conclusions were drawn based on the wrong. Mm-hmm. No, smoking here is a confounding variable. Drinking is your independent variable, right? And lung cancer is the outcome variable. So this alcohol intake is rather your independent variable. But that there is a high relationship, high effect of or close relationship between drinking and smoking, such that something happening in smoking, you want to conclude that is the same thing that's happening with drinking. And so because it's happening in smoking, that's the same thing that was happening with the same way they will affect lung cancer. But you can segregate and discover that you take away smoking, the effect on lung cancer will be different. You'll get it. Yeah. You control for it. You control for it, yes. Okay. So that's it. Any question again with respect to variables? So another exercise to write down 5. Research topics clearly indicating independent variable confounder, moderators, and mediators where applicable. At least that can be a good one to do. Just from research topic, identify which is a dependent, which is an independent variable, and if there are other variables that will affect your dependent variable, just for the sake of understanding. Now, after variables, the next is levels of measurement. I don't know. Should we take this today? This is a critical. Yeah, 2 days. But we have not gone far. We still have a lot. Yesterday was orientation now. We have started today. No, yesterday was orientation. We started. Normally we had orientation. I'm afraid that your brains. Let's see, sharp. Oh, okay, we should finish because. Okay. Frank. So, yeah. Although they're complaining, time is long online. People online. Online, they're always distracted. So, yes, online persons they always have a lot of distraction. But we'll make progress. So, levels of measurement. This is one important topic that you should take into account. Key concepts. It's not like what we have seen last time. It's not. They're not important, but this one and variables they influence your daily duty. Sampling population may not influence your daily reality that much, but these ones they're critical for you to understand. But you must not get everything today, but try to get everything if you can and get as much as you can. So when we collect data, whatever form and wherever source we get the data, That data will come in one of four ways. The data can be nominal, it can be ordinal, it can be interval, it can be ratio. Whether the data was quantitative or qualitative, right? It can be in these categories. So levels of measurement tries to categorize different data sets that we collect to help in analysis. Before you analyze every data set, every variable, before you run analysis, you must always, as a first condition, know the level of measurement that the data is. Because the level of measurement affects the analytical technique that you will use. It influences which techniques are more ideal. Do you get that? If your level of measurement of the data is nominal, you know that there are some particular techniques that will be ideal. If the data is ordinal or ratio, you need to know which techniques. Now, broadly speaking, we may want to categorize data into two: categorical data and continuous data. Which means we are looking at the four levels of measurement and we further divide them under two headings: categorical data and continuous data. With categorical data, as the name simplifies, it means it's this data type that objects or elements are classified under different categories. Categorical. When I say gender, you automatically put either male or female. Those are the two categories and they're finite. But I say salaries. Now what happens? You can start from 0 to infinity. You get it? So it's a continuous variable. We may come and take a continuous variable to categories and say low earners, high earners, right? But then we have a potential to have multiple outcomes, which are kind of infinite possibilities. That's one way to get a difference. Now, the categorical data takes on nominal and ordinal. So what is nominal data? Nominal data basically is a data that has finite options without any order. Male and female, there's no high, no low, right? There's no order that we can say male are better than women. Or colors, red, green, red. If I like red and you like yellow, doesn't make you better or this and that. There's no hierarchy. So this is the most primitive on the basic data classification. But ordinal data, while it also has different categories, but there is a kind of an order. We can arrange from the least to the highest. First, second, third, right? Strongly agree to strongly disagree, whatever classification we want to put. What is important? We have an order. Now, the difference between nominal, ordinal, is that we can put nominal under categories. We cannot say which one is higher, but with ordinal, we can say this one is higher, right? The first person can be considered more intelligent than the second and the third and the rest. But there is another thing that ordinal data fails to capture, which is the distance between one person and another. We have equal distance, right? What is the difference between the first person and the fifth person cannot be quantified. We're explaining, yes, under not ordinal, but that leads us now to the next categorization, which is now under continuous data, which is interval and ratio. For the interval data, right, what happens is that there's a possibility for us to know that there is an order, right? We can arrange from the least to the highest, but we can equally calculate the distance between each variable and the order, or each item and the order. For instance, what's the difference between two brothers in terms of age? One may be 2 years, right? So you can take out that difference. But what is the difference between first and second? You cannot capture the difference between them. You get that? Yes, that is the aspect of interval data. We're able to carve out interval. And now the ratio. Well, since it's continuous, you can always have the order. You can always have the order, right? For instance, 10 is higher than 5, right? 20 is higher than. And so most often people classify continuous data to be things that are measurable with units and you can count easily. What's the unit for colors? We don't have a unit, right? We don't actually have a unit for colors, but we can have a unit for ages. We can have a unit for distance. We can have a unit for, so you discover that attaching unit, what's the unit for currency? France, we have currency like what money we use in Cameroon. It's France, right? So most of the things that have units can be classified under what? Continuous data. Now, under continuous data, which we may still divide into discrete and continuous. Do you get that? And we can still divide into discrete and group data. Those are some things that you need to know. We have group data. But that is not. But the last data categorization that we want to see is the ratio. Now, for the other ones, 0 was not really that of importance, but for ratio data, 0 becomes important. 0 does not signify the absence of something. That we say temperature is 0 degrees. It doesn't mean there's no temperature, right? Yes, there's still temperature at a certain level. And so principally, as a researcher or as a data analyst, you need to understand this different categorization because they have a lot of influence on the choices that you take with respect to analysis or analytical techniques. So understanding them is critical. So having said that, there are some key questions that may help you to do that categorization when it comes to application. And the questions that we have. If you ask yourself, what I'm measuring, do we have an order? And the answer is no. By default, it's nominal. Right? If you ask yourself, do we have some equal distance between? And the answer is equally no. Same distance, right? Then it's nominal. But if the answer to that is yes, then it cannot be nominal. Do you get that? So if I have an order, I don't have an equal distance, then we're under ordinal data. Because I have an order, I can put from the least to the highest, or from the highest to the lowest, or whatever order I have, right? But I cannot know the difference, cannot quantify the exact gap between one element and the other. So although I have an order, but there is no equal distance among the items, so it will be ordinal. But if we say there's an order and the distance and the distance between one and the other can easily be factored out, then we can classify that as what? It is either ratio or interval data. Now, either under ratio or interval data, the difference comes in with absolute 0, which means we think that 0 plays a role. 0 has a role to play. With the presence of 0 signify the absence of the thing, or the thing will still be. In some cases, some people argue that maybe the possibility of taking on negative values, right? The attachment that it is data that has to do with units that we can easily attach units. Those are now out of experience. Maybe a textbook might not give you directly, but that is how, for me, the method I use at times to do my own classification. It might be valid, might not, subject to research, and you can debunk that. You get that? But these are critical things that will help you to take that decision. Now, like I said, it's important to take note, and it's important to know that your final analysis or whatever analysis has a lot to do. So we'll be seeing 8. When we get to application, we'll still be saying we'll take our data, we'll try to see how it is categorized before we analyze. So don't be frightened. We will get the concepts.
So,
yes.
Then the difference between final and ratio also is infinite. It has
Infinite, the word infinite there might be, the way you take infinite there, for instance, when you're looking at somebody's age or max, you may have 0 to 20 now. So actually, there seems to be a finite, but then we have different possibilities. There's somebody with 1.1, 1.25. So the options are so many. Let me put it that way, so that the infinite should not mean as if the only thing is infinity. You get the idea? Yes. But the only difference between ratio and interval is the presence that 0 still makes meaning. 0 does not signify the absence. It's like the variables can take on negative values and will still be valid to an extent. That's how it tries. Yes. Yes. I mean, for interval, for instance, you see from the slides, the temperature we have negative temperature, and it still makes sense, right? So which means the rest of values here doesn't start from 0. All right, it starts even below 0. That's the reason. Yes. So, but then in application, many at times, there's not even between interval and ratio. That's where a program like SPSS takes just SPSS that we'll see has 3 categorizations. We have nominal, ordinal, and scale. So they group the 2 to be scale. You get that? So these two will not try to differentiate ratio and interval in application that much. It's in rare situations. So something like the telephone number, where will it fall? Those are things I need to start doing classification. So once you've understood this, then you're on a good footing as data analysis is concerned. We already said it, continuous or numeric data can be considered as, we can say it scale or continuous data, right? Or discrete. Discrete has to do with whole numbers. The other continuous now has to do with ratios, fractions. I should go back here. You already have in the slide.
And now, what about the issue of what?
Yeah. This doesn't exist.
So in case of interval, when we see you can see as when you go to ratio, if there are any 0 frames, if you are not any
Zero age means you are not conceived. You are not conceived. It's just I want to take age now in terms of years. It's not sure. Who said age is only measured in terms of years? You can measure. 0 year means you are not existing. So there is no existence of that particular. Do you get it? 0 is significant. It's only a ratio that 0 is not significant. but under interval 0 still make meaning. Now, he used the example of age. We are measuring in years. Somebody not up to 1 year still has, we cannot say that the person does not exist. You get it? Because age, though we take years, maybe the whole, but we can still have 0.2 years, 0.1 year. Yes, in weeks, in time, in seconds. You get it? Yes. But there are situations that the value 0 is completely relevant. Now, I don't know where are we going to classify, for instance, when you get a mark of 0, how do we put it? Are you sure? You can still write and have 0. You can write and have 0. Okay. well, in application, the tool might not be that explicit, right? Yes, and one of the vivid examples is always temperature, because it goes below 0. Yes, that's it. That's classification. Point. Absolutely. Do you get it? So at the end of the day, like I said, for the simplicity of our understanding at this stage, right? Let's know that interval and ratio are continuous scales. In very few situations, we'll have to battle with whether it's ratio or scale in our application. I have not experienced a situation where I need to really classify that this one was ratio or interval, right? My own experience. And that's why I said other programs even treat them as just one. You'll get that. So that should not be a major worry because it doesn't influence our analysis that much. We are looking at things that are major and that can affect our conclusion if we ignore. So we ignore whether it is interval or ratio, but understand that it's scale data or continuous data to make that differentiation. Then we'll still get the same outcome. Okay, we're running out. This is the last. We're almost done. So, I think that is clear, right? It's obvious. But we'll be discussing this as we move on. So I must not get everything today. So, having done that, I believe the last thing is exercise. So you go and try to do this exercise at home since our time is finished. So we have taken the key concepts, about 4 of them for today. We'll come and see the other ones, and from there, the other ones will just leave it. Go and study them, and I'll check if I can share the previous video for people to go through and see maybe the rest of them can just come. So if you don't have the program, we're using HPSS. I think the next class come along with your machine so that they install. If you have it, no problem. So with that, I'm sure we come to the end of today's class, and we have to go. Yes. No, but the key concepts are vital. These key concepts are vital. We cannot ignore them. If we ignore them, preferably we should ignore some certain things to study, but not these key concepts. Because they lay the foundation. A good foundation building becomes easy. So we come to the end of today's class, and so see you next Sunday.